Let's start. My talk is going to be how to create your own fractal puzzles. My name is Frans Faase and I'm currently working with KIT Engineering, one of the main sponsors of this event. And I'm also a member of the local hackerspace called Tucker Lab. And how did all this start? Okay. So what is going to be the content of this talk? First I will talk about what are fractal puzzles, how do they look like. Then I will talk a little bit about the theory about puzzles. And then I will talk something about software that I created to create your own puzzles and explain how you can use it. The talk is also online and as you can see, okay, let's start. This is what it started with. Run the video. This shows a fractal puzzle that was designed by Oscar van Deventer. And this shows the nice thing that the pieces disappear once you put in the last piece. Now. So this is the puzzle that he has made. You can still buy it from Etsy, from his website. There's a link in here. If you open the notes, then there's a link to it. Now, how does this piece actually look? Now, here are all the pieces that are all given a separate color. And so you can see how many pieces there are and how they fit together. And what I would like to point out is that there are some pieces which are not really very nice. I felt like pieces like this. You see that there are some lines inside the piece itself, so it's not actually as separate as you would think. Now here there is some small diagram that is showing how are the pieces actually put together. And then you see that actually the pieces are made up of triangles with round shapes that are connected at some connection points. And you see that there are different ways that the triangles are connected. So when I saw this, I immediately thought like, okay, there are some places where there are two triangles that are touching side by side. Here in the corner, for example, there are 3 of them that are touching side by side. And I asked myself, can you also make puzzles that do not have this? Because I think that looks better. So I started making some drawings and to try to figure out how are these fractals created, how are the shapes created. And I came up with some letters and some symbols. And one thing that I noted is that every time it consists of arcs that are 1/3 of a circle. And the most simple fractal, that's called G1, is just an L turn followed by an R turn. And if you go to one more complicated, it is like you put the LR in between the 2 LRs. So you get LR, L, LR, R, and LR. And you can, if you continue with this, you can go on with this and it goes further and further. Now, I made some animation about this. Here you see a simple form. Now, actually that is equal, this is the most simple one. You just have one turn, one direction and the other direction. And if you select the second one, it gets a little bit more complicated. And then the third one, yeah? Yeah, that's right. How it works is that here I've put 3 of them together, a red, a green and a blue one. And to make a full circle you need also a gray one. So if you go to 0, you get just a circle. And then you take the 1 and you have the 3 gray parts that make up one circle. And then you have 3 connection parts. So then you can go to 3, 4, and then also 5. Yeah, the gray part you always need you always need to repeat. And here I can also switch this one off and then go like this, and then you see that it's actually every time when you go one deeper, it is that you put in, you make it 3 times as large. Now if I sync it again, you see it turns a little bit to make it. So this is the basic principle of making the triangle shapes. And the question is, how do you put them together and to make them in a more interesting puzzle? Because if you have just a puzzle of triangle shapes, it's really very easy. You just have to put them in there. So actually this is called a so-called space filling curve, because the higher you go, the more space it covers. And the person who started designing this is Giuseppe Piano. That's a mathematician who came up with this idea of space filling curves. So if you look at the puzzle, then again at a more abstract level, you will see that it's made out of triangles and certain connection points. So in this puzzle there are 33 triangles and 19 connection points. So if you want to make a puzzle, it means you have to make some pieces now. And each piece has to consist of a number of triangles and also some connection points. And for a correct solution, the pieces cannot overlap. In a normal puzzle, you don't have 2 pieces on top of each other. And also all triangles need to be covered. Otherwise, there are empty spaces. Now, this looks like a mathematical problem that's called an exact cover. Because it says it exactly covers everything. That's the idea behind it. And there is a famous computer scientist, Donald A. Knuth, who made algorithm X to solve so-called exact covers, and he made use of a technique that is called dangling links. I'm not going to further to explain this, but he is well known for this. So if you want to design a puzzle with these kind of pieces, you have to make some decisions. And the first things you have to think about is what is going to be the perimeter? How big is it going to be? Now in my case, I did not change the size, I just kept it as it is. And then another thing is what is the size of the pieces? How many, from how many triangles will they be? Do I want to have a puzzle with all small pieces, or do I want to have a puzzle with large pieces that have many triangles? And another thing is the variation of the pieces in the solution. Do I want to have small pieces or only long pieces? And then there's also, you could also have puzzles where there are multiple copies of the same piece in the puzzle. Like the one that, I don't know if anybody of you have played with the red or the blue puzzle that are down here, but they have 2 copies of 2 pieces. And then another thing that you can ask yourself is like, do I want to have the puzzle one solution or multiple solutions? And then the last thing is that you can think about is, do I want to create a difficult puzzle or an easy puzzle? And there's some interesting relationship between the number of solutions and the difficulty, and that I will talk about later. So I wrote a program, it's called Piano Frac. I spelled the name of piano a little bit wrong, so I made a Piano Frac. And that's the program that I developed to create all these puzzles that are down here. So the first thing that you have to do is to generate the pieces that you want to use in your puzzles. And this program has several commands, and one of the commands is gen-ec. That stands for exact cover HC, and that is HC stands for hard-coded. So that will generate puzzles of pieces with the hard-coded set of pieces that are also in the original. No, I don't think so. A set of hard-coded pieces. But you could also use another method, and there you can specify a range, and that range specifies the size of the pieces. So here we have used the range 2 to 4. That means that our piece is going to be in there with sizes 2, 3, and 4, but not with 5, and not with 1. Now, how do you call this program? This is a Unix command, and I used the pipe symbol. So here in this line we call 3 programs, but we put the output from the first program into the second program, and from the second program in the third program. So we generate here the pieces with sizes from 1 to 5, and we also use the option with name. You have to use that. And then we call the program exact cover, and that will, with those pieces, find all possible ways to fill the shape with the pieces. And because the puzzle can be rotated in 3 steps, we call a normalize program, and then also give it the option minimal to take out all double copies. And that we put in the file that is called sol.txt. That's all the solutions with those pieces. But then we don't have the puzzles yet, because a puzzle can have multiple solutions. And so in this file are all the solutions, so also we have to group them together to get the puzzles. Now, we use this command that says used pieces, so that takes from every solution, it looks up which pieces are used in there, and it puts it in a list. And then we use the built-in sort command and a unique command with the -c option that will count duplicates, and then we sort it again. So this will result in a list of all the puzzles that are sorted from the least number of solutions to the largest number of solutions. But that still returns a lot of puzzles, a really large file, I can tell you. So maybe you want to have to filter something, and so the first command shows how you can filter the puzzles on the number of solutions that there are. So if you use the min 14 to max 16, it will have all the puzzles that have 14, 15 or 16 pieces. Now, then you can also filter on the number of duplicates per type of piece. So you can say, for example, I want to have a maximum of 4. And then also you can filter on the maximum number of duplicates in the whole puzzle. Now, if you have gone, and that will reduce the size of the file with the puzzles. And then you can go through it, and then you can see, you get all the sequences like this, which numbers all the pieces in there. And this just says that there are 3 pieces of type 1, 5 of type 2, and so on. If you have found one line and you want to see how it looks, you can use this command, and that will result in an SVG file. And if you open that in the browser, it will look like this. I've used here the spaces is 2, and that will result into that there is some distance between the pieces. And I will later explain why this is important. Okay. So what are the puzzles that I've made? Now, the first one that I've made, and that's also in the photo in the background on the website, that's this one. And it looks, I don't know whether you can see it, but it looks very fine. But it has one problem, that the pieces almost cannot come out because they are too close together. And I've cut it with a single line. And that makes it very hard, it makes it that pieces almost stick together and that they're very difficult to get out. There's also another problem with this one, is that the laser printer, the ratio of the X and Y direction was not exactly 1. So if you take one out of the pieces and you put it in wrong, you will not get it out ever anymore at all. So that's why we started with the 2 lines. I have an example of this. This is quite wide. You can also see that the pattern that is in between, that is this pattern. So that's just all the lines that you saw. So these are the first two that we made. And then my daughter had some major in her study. And she said, okay, I want for this major, as this subject, I would like to make a puzzle, design it. And that's why we came up with this puzzle. It looks quite small, but it's actually 10 puzzles. So how you do it is that you get one of these papers. And there's also here and back with more pieces, 29 pieces in total. Here on one side it says which pieces you have to take. And then if you cannot find a solution, then it's on the back. You could also make a photocopy of this one and then cut it out and then put it inside the puzzle. So if you have small children and you want to teach them how to fill the puzzle, you can just photocopy this, cut it out, put it in the puzzle and teach them how to put in the pieces. That's already quite difficult for a small child. And it also says the number of solutions and the difficulty. Now, and then we also made some larger puzzles. So, now we talked about the difficulty again. I wanted to know if there's a relationship between the number of solutions for a puzzle and the difficulty. So you would expect that if a puzzle has only one solution, that it must be more difficult if it has many solutions. Now, is this really the case? And how do we define the difficulty of a puzzle? Now, I've written a program to find that out, to calculate that, and I've said, okay, the difficulty of the puzzle is based on the number of tries that you have to do, if you would use the most optimal solution strategy to solve the puzzle. So I've assumed that you are a very good puzzler. And yeah, most people, when they see the puzzle for the first time, they have difficulty to see how the pieces fit in. So for beginners, this is not really completely honest. But yeah, there's no other way to define the difficulty of a puzzle. Okay, so I've come up with this graph for all the puzzles that I had generated. And you see that from left to right, it is the difficulty, and from top down, it's the number of solutions. Now this graph, it really looks a little bit, yeah, most of the points are in the corner, and that's because there are many puzzles that have just one solution. So they're all in the top line here. And also there are more easier puzzles than there are difficult puzzles. So I decided, okay, I will divide all the puzzles into 10 categories with respect to difficulty, and 10 categories with respect to the number of solutions. And that resulted in this table. So you see that some of the categories are a little bit larger than the others. For example, these are all the solutions with, all the puzzles with one solution, did with 2 and 3, and this is 4 and 5, I think, and so on. And the highest number is something like 600 solutions. And so what do you see is that if it would be completely equal spread out, then every square would have the number 100. So if it's lower than 100, then it's less solutions than you would expect. And if it's higher, darker, and also higher than 100, then it's more solutions. And so what you see, it's still quite gray, and there's not much. The only things that you notice that there are not so many puzzles that are very difficult and have many solutions. That's a little bit what you would expect. And yeah, it does seem that there are, if you have a very difficult puzzle, then usually it has only one solution. And if you have a very easy puzzle, then it has, if a puzzle has many solutions, then it's a lot easier. But still, it's quite gray. So you can have puzzles that have only one solution and are very easy, like these, and also very difficult. So how is that possible? That there are puzzles that have only one solution and are still very easy. Now that is because these are usually puzzles that have large pieces that only, if you think about it a little bit, can only fit in one place. So if you reason well and if you're smart, you start with the big pieces and see where I could fit them, and then you see that are only three places, that are only a few places left. For example, this red puzzle, the red and the blue puzzle, they are relatively easily because they have three large pieces that only fit on the borders, and there are only two ways you can place them. And then there's another large piece, and if you know where you fit it, then it's very easy to solve the rest. So this is my talk. Has anybody some questions? Huh? Yeah, actually my daughter is still selling them, and her website is Annabelle Esther, without an H. And she's selling all the blue and the red puzzle, and you can choose the color you want to have and also the difficulty level. So she has 3 difficulty levels. And of course the small puzzle, she also sells this still, and then you get actually 10 puzzles or more if you can even design your own puzzles. No, there is no, I've not made a website yet where you can make them online. No. Nobody else? Yeah, okay, then this is the end of the talk.